Okay, so we've had the theorems about the special segments, how we have the orthocenter, the incenter, the circumcenter, and the centroid, and how each of those has a meaning except for the orthocenter, which really doesn't seem to have any values within the triangle other than the three altitudes where they come together. Now that's part of understanding triangles. The other is this understanding what we call the inequalities within the triangle. Because the angles are different sizes and the sides are different sizes, different things happen from that. So this video presentation today is about those inequalities. Let's start her out here. Okay, so we're looking at our inequalities. The first thing we have to understand is what an inequality is. For any real numbers A and B, A is greater than B if and only if there's another positive number C that if I add it to B, it equals A. So like 6 is greater than 4 because 4 needs to get 2 added to it to become 6, and 6 is also greater than 2. Now there's a ton of properties that we have back in Algebra 1, or from algebra, or even 8th grade math, or even lower than that. You have the comparison property if A is either less than B, A is equal to B, or A is greater than B. Again, you have a transitive property of these. If A is less than B and B is less than C, then A has to be less than C. Likewise, if A is greater than B and B is greater than C, then A has to be greater than C. We can add and subtract in these just as well. As long as I add the same amount to both sides or subtract the same amount from both sides. I can multiply and divide in these, but remember this is where the trick comes in. If C is negative. So if the number I'm multiplying or dividing by is negative, we have to flip the inequality. Notice it went from less than to greater than, or greater than to less than. That's that one trick. Otherwise, you can multiply and divide on both sides without any problem. But if you do it by a negative, you got to flip the inequality. We had that stuff in algebra. You've already talked through that. So how does this work in triangles? So we have our angle inequalities. The first one is the exterior angle inequality theorem. And if an angle is an exterior angle of a triangle, then this measure is greater than the measures of either of the corresponding remote interior angles. We've already talked about an exterior angle and remote interior angles, but let's review that real quickly here. Let me change this to a highlighter. Oh no, let's just go to the magic pen. Okay, so we're looking at this figure here. Angle 4 is our exterior angle. And that means angle 1 and angle 2 have to be the remote interior angle. They're the angles that don't touch that one on the outside. So this theorem is saying that this angle 4 has to be larger than the other two. Well, that makes sense because we had the exterior angle theorem, which said angle 4 has to equal angle 1 plus angle 2. So if those two added together equal angle 4, that means 4 has to be bigger than both of them. There was your proof of that theorem. But that should be kind of obvious to you as well. Okay, the other one is if one side of a triangle is longer than another side. So if RP is longer than PQ, then the angle opposite the longer side has a greater measure than the angle opposite the shorter side. So if RP is the longer side, that means angle Q is the bigger angle. If PQ is the shortest side, that would mean angle R has to be the smallest angle. So if I know the lengths of all three sides, I can tell you which angles are going to be bigger, smaller, in the middle just by knowing the sides. Opposite the longer side is the bigger angle. Opposite the longest side is the biggest angle. Opposite the shortest side is the smallest angle. Okay, that's basically what that theorem is saying. So if I know the side lengths, I can figure out which angle is bigger just knowing that. Now, the converse of this is also true. If I knew the angles, then I should be able to figure out which sides are. So if one angle of a triangle has a greater measure than another, then the side opposite the greater angle has a longer side. So if I write this up again, opposite the biggest angle is the longest side. And likewise, opposite the smallest angle is the smallest side. That's right, and we'll call it shortest. So small and short go together, big and long go together. Okay, I call that the angle to side inequality theorem because we're using the angles to figure out which sides are bigger. And the other one was the side to angle inequality theorem because we started with the sides and went to the angle. Now these both kind of play into the isosceles triangle theorem in that if I had two sides that were the same length, the angles had to be equal. This is just kind of an extension from that. So what can we do with that? What are we going to see as far as assignments are concerned? We're going to see problems that look like this. Determine which angle is greater just based on that figure. Is 1, 2, or 4 greater? Well, 2 has to be greater because 2 is the exterior angle of that. Is 2, 3, or 5 greater? Well, 3 has to be greater because 3 is the exterior angle where 2 and 5 are. So which of these angles, 1, 2, 3, 4, or 5, is going to be the biggest angle? Well, we know 2 is bigger than 1 and 4, and I know 3 is bigger than either 2 or 5, so that must mean that 3 is the biggest because of the transitive property. And I can go right down the line. Since 1 is smaller than 2 and 2 is smaller than 3, 1 is smaller than 3. 3 is bigger. Since 4 is smaller than 2 and 2 is smaller than 3, then 3 has to be bigger. If 5 and 2 are less, okay, you got it. Okay, we're going to skip that next set. Let's look at this part here. These will be the next ones. Okay, so we've got this figure listed out here, and we need to determine which angle measures, determine the relationship. Okay, so basically we want to know which angles are bigger. Is WXY or XYW bigger? WXY is that angle. XYW is this angle. So now when I look at that, I look at the opposite. Opposite this angle is a 12. Opposite that angle is the 14. So which one's bigger? The WXY is bigger. So it's a greater than angle. XZY, and XYZ, so that goes to that side, and that goes to that side, and 18 is bigger than 15, so the angle Y would be the bigger angle, so it's going this way. So that's what we do. We got to look at those. Now remember, and I think some of you had this problem on one of the other assignments. This name tells you how to find the angle. The middle letter is the vertex. The other two letters tell you where to start and where to end, but you've got to go through that vertex. For me, I have to draw it out. Okay, so now let's look at this bottom problem. Determine the relationship between these lengths. AE, right here, and EB. Well, let's see. AE is opposite the 30-degree angle. ABE is opposite the 110-degree angle. EB is definitely going to be bigger. So we find the bigger angle. Opposite it has to be the longest side. So that's the type of problems you're going to see on the assignment. Okay, let's go back real quick. There we go. So these really here are the two big theorems I really want you to understand for this assignment.